Hi, my name is Cosimo Pecchioli and I'm with Alfa Laval Data Centers Cooling Solutions. And this is the third video of a series of videos about gasketed plate and frame heat exchangers. In this video we talk about plates. So let's have a look at the main areas of a plate. These are the ports, and please note that they are not round. We'll come back to that. This is the distribution area. In older design, it was called the chocolate pattern because it resembled a chocolate bar. The distribution area has evolved over the years, and this is the latest design that Alfa Laval introduced a couple of years ago. Other vendors still use what is called the chocolate pattern. The evolution of the distribution area alone could actually be a good topic for a future video. This is the main heat transfer area, and actually this topic could fill many videos. The pattern that you see here determines what kind of heat transfer you have in the plate at the cost of the pressure drop. There are pros and cons of all the different designs. We will probably come back to that in future videos. This is the gasket groove, and it's not just a bend in the plate. Actually, it is carefully designed to make sure that the pressure applied on the gaskets seals the heat exchanger when you compress them. And of course, this is where the plate hangs from the carrying bar. The hardest part in designing a plate is make sure that the distribution is even across all the surface, taking in consideration that the inlet port is offset. So here is a brief animation on how the fluid is distributed inside the heat exchanger to clarify this concept. In this animation, you see an example of a blown up heat exchanger with all the components we mentioned before. Here you have the hot side inlet, and pay attention to this gasket. You see where the gasket seals off this plate and does not on the next plate. This pattern alternates, allowing this fluid access to every other plate. This same gasket pattern is used for the other fluid, permitting this fluid access to the other side of the plate. The result is each plate has one side one fluid and the other side the other fluid, traveling counter-currently to each other. Through counter-current flow, it's one of the reasons gasketed plate heat exchangers are superior to other types of heat exchanger. We mentioned the importance of fluid distribution across the plate earlier. Let's have a look at this. Here it is. Here you can see the hot fluid entering the port and being distributed along the plate. A lot of research and development goes into fluid distribution. Prevention of dead spots where there is no heat transfer and fouling can build up is one of the key to efficiency. So this is how a plate works and how the liquid travels through the plate. For this video, we would like to remember that the distribution area, including the design of the ports, is a key element in the efficiency of the plate.